Chapters 10.1, Angular Displacement, Velocity and Acceleration, and Chapter 10.2, Rotational Kinematics.
By Manan Manjia,
Paul Wolkowski,
Kimberly Clavin,
Andrew Shang.
Go
Go
Soon
Soon
Kim, Go Soon Kim,
Kim.
Kim.
In this chapter, we are dealing with rotational motion. When dealing with a rotating object, analysis is simplified by assuming an object is rigid. A rigid object is one that is non-deformable. That is, it is an object in which the separations between all pairs of particles remain constant. Rotation of a rigid object about a fixed axis is pure rotational motion. In this chapter, we will be using polar graphs, r, theta. A polar graph has a series of concentric circles for r and has lines referencing the angles. Also, r times theta equals s, the length of the arc. Note, theta must be in radians. In order to convert degrees to radians, radians equals pi over 180 degrees. Angular displacement is change in theta, which is final theta minus initial theta. Average angular speed is the average of rotational velocity, or omega, which is final theta minus initial theta over final time minus initial time, or change in theta over change in time. Instantaneous angular speed is omega, which is the limit as delta t goes to 0 of delta theta over delta t, or d theta dt. Average angular acceleration is average rotational acceleration, or alpha, which is final omega minus initial omega over final time minus initial time, which is delta omega over delta t. Instantaneous angular acceleration is alpha equals the limit as delta t goes to 0 of the change in omega over the change in time, or d omega dt. When rotating about a fixed axis, every particle of a rigid object rotates through the same angle and has the same angular speed and the same angular acceleration. These are the rotational kinematics. Please note, constant acceleration, or alpha, is necessary. Please also note that these are the same as linear kinematics, adjusted for rotations. Questions?
You must answer these questions correctly.